Good morning. I want to show you guys another kinematics example problem. This time the car, same car I guess, is accelerating from rest to 30 meters per second in 20 meters. How long did this take? So we're solving for time. So I went ahead and I wrote out our known variables. So since it starts from rest, we know our initial velocity is 0. It tells us our final velocity is 30 meters per second. It tells us that displacement is 20 meters. We just need to find time. So we need an equation that has velocity, it has velocity final, it has delta x, and it has time. I think we're going to have to solve for acceleration again in order to figure this out. So let's go ahead and do that first. We know that velocity final squared equals velocity initial squared plus 2a delta x. So we know everything here but acceleration, and we're going to need acceleration to solve for time. So let's solve for acceleration. To get a by itself, we are going to first subtract v naught to the other side. Okay. And then I'm going to divide away the 2 and the delta x. So I have a by itself. 2's cancel, oops, the delta x's cancel. So I am left with acceleration equals velocity final squared minus velocity initial squared divided by, apparently I left an a, 2 delta x. Okay, great. Let's plug in our values. We know that velocity initial is 0, so we don't even have to worry about that. We know that our 30 is our velocity final. We got to square that. We got to divide that by 2 times that 20 meters. So we need 30 squared divided by 40. So that says 22.5. And remember, we're solving for acceleration, so that's meters per second squared. Great. Let's go ahead and write that off to the side. And that way I can erase this, and we can solve for time, like the problem originally asked us to do. Okay. Erasing. Okay. So now we can pick a different equation, one that involves acceleration, velocities, and time, so we can get solve for time. All right, so we can say velocity final equals velocity initial plus a t. And now we know all of these things except time. We just need to get t by itself, so I'm going to subtract v naught to the other side. And then I'm going to divide away a on both sides. So we are left with time is equal to velocity final minus velocity initial divided by our acceleration. We know that our velocity initial is 0, so we can cancel that out. So we can plug in our values. So time is equal to that 30 meters per second, our velocity final, divided by our acceleration, which is 22.5 meters per second squared. So we go to the calculator. I do 30 divided by 22.5. And that's going to give me 1.33 repeating seconds. Pretty fast. Okay, cool. That's where we're going to leave off. We've solved for time. We're done. If you have any questions, please let me know.